This one is tricky. It's not terrible. Really what it boils down to is if you see the terms alternate and the signs alternating, then you know you're going to have negative 1 to a power as part of your rule. Okay? And so what you can always do in a case like this is just do negative 1 to a power times whatever's going to give you the values. Well, what numbers are those the powers of 2 again? And this is 2 to the power of 3, and this is 2 to the power of 4, and so forth. But you start with n equal 3, so it's just 2 to the power of n. And once again, there could have been a disconnect. What if I just, if I change this to say n starts as 1, what would my rule be? 2 to the power of what? N plus 2. I mean, this is 2 to the power of 3, 2 to the power of 4, 2 to the power of 5. You can't change that fact. I'm just saying, if this was supposed to correspond to n equals 1, well, 1 plus 2 is 3, and 2 plus 2 is 4, and 3 plus 2 is 5. And so it's not just n, it's n plus 2. I'm just saying, sometimes it happens, and you have to kind of make adjustments. So, well, so it works. Now, look, just for the record, what I put here, will that start with a negative like it's supposed to? You start with n equals 3, and negative 1 to the power of 3 is a negative. So, which means you can really just write this as negative 2 to the power of n. Okay? But, actually, let me write the final answer. We weren't supposed to just find a rule for those numbers. We're supposed to write a summations, sigma notation for that series. Well, n starts out as 3. The rule is simply negative 2 to the power of n. And the upper limit is what? Because 512 is 2 to the power of 9. And so that's the actual answer to the question, not that. The other little tweak I want to make, or point, is they can make it more interesting or more complicated, depending on how you want to say it, if they switch the signs around. So now this wouldn't work. What exponent would have to go here to make it work? Like n plus 1? Because if you start with n equals 3, then that 3 plus 1 is 4. Negative 1 to 4 is a positive. So they could be tricky on you like that, is all I'm saying. Probably won't, but they could. So. All right. Any other questions? And let's finish up the notes from yesterday. And so we just use this formula once on this problem. Here's the next one. Write this down. Okay, seriously, when I say take up the notes from yesterday, I mean do it when I ask you to. And it would probably be good to take out the green formula sheet as well. All right. Listen, you need to know these formulas. And once again, this formula works to find the sum of an arithmetic sequence. And how do you know it's arithmetic? Because it's decreasing by how much every time? More? You're actually 22. But it is a constant difference, so therefore it's arithmetic. Now let's start plugging in. And actually, I want to address this terminology here. It says find the 17th partial sum, which sounds kind of weird. The reason they phrase it that way is because this thing goes on forever, right? It does. But think about it. If it goes on forever, it very quickly gets into being negative numbers, right? And if you were to sum up the whole thing, well, it's just going to be negative infinity. It doesn't actually sum up to some number. But if you sum up just some of it to partial sums, then you get a numeric answer. Have I talked about Zeno's paradox, by the way? Okay, I guess it was only first grade. So here's the idea. Because my point I was kind of getting at is there are certain times you can sum up an infinite series and get a number. So here's Zeno's paradox. He showed that motion is impossible, right? So here's his logic. if I want to get from here to that wall, all right? He said, well, you first have to get to the halfway point, and then you have to make the next halfway point, and then the next halfway point, and then half of that, and half of that, and half of that. And there's always going to be half, something to take half of, isn't there? And so that process will never end. But we as humans can't do an infinite process, and therefore motion is impossible. Of course, he knew that's not true, because that's why it's called a paradox. I can, of course, make it all the way across there. Mathematically, think about this. What I'm adding is half, and then what's half of a half? A fourth. So it's a half plus a fourth, plus an eighth, plus a 16th, plus a 32nd, plus a 64th, on forever. And if you turn that, if you add up a half plus a fourth plus an eighth plus 16th, the whole thing, the sum is 1. Exactly 1. Now, if you added part of it, listen, if you add a half plus a fourth, what is that? 3/4? An eighth added on makes it 7/8. Add on 16th, you're up to 15/16. 31 over 32, 63 out of 64, 127 out of 128. And you can see the sum is approaching 1, getting closer and closer to 1. And if you stop short, it won't be 1. But if you could add up the whole thing, it would be 1. Which is basically what we do every time we walk across, a distance. Or summing up an infinite sum. So I'm just saying, it can happen that an infinite sequence adds up to some number. Usually, though, it goes to infinity, or negative infinity. So, if it ever asks you to find the 17th partial sum, it just means sum up the first 17 terms. That's all it's asking to do. Which is exactly what this formula is going to do for us, right? So, let's actually do the problem now. In 17, the first term is, I think, 53. The last term we don't know yet, so we're going to go find that out. So we use that other formula you learned yesterday. That'll give us whatever term in the sequence we want. This is the first term, so that's 53. The common difference we already figured out is minus 22, so put minus 22 times n minus 1. And once again, the logic is, like here, we're trying to get to the 17th term. To get from the first term to the 17th term, you'd have to subtract 22 16 times. There's 16 jumps between the first and 17th term. That's why it's n minus 1 there. All right, do the arithmetic. I'll leave it to you to figure out 22 times 16. And then when you subtract, you get negative 299. So that's the missing part that we need in our formula. We need to know the 17th term, and now we have it, so plug it in. Then if you start working this out, those numbers, when you add them, you get negative 246. And I would cancel first. And half of 246 is 123. Which means now you have to crank out 123 times 17. By the way, it's really a negative times a positive, which means the sum is negative. Just pause and look at the screen. At first glance, you might say, well, these are all positives, which doesn't make sense to get a negative sum. But like I said, really, the very next number is negative, and after that, it's a whole bunch of negatives. So it does actually make sense that the answer is going to be a negative. You should be thinking like that, checking, making sure your calculations match reality, that it makes sense. It should get around 2,000. 2,000 what? 91. If you didn't get 2091, check your calculations. Listen, that's it. It's not horrible, but you have to, first of all, know that since it's arithmetic sequence, that's how we chose this formula. I know we haven't learned the geometric yet, but once we do, you'll have to choose, right? So choose the right formula, and then you realize that a lot of times you don't have everything given to you for the formula, so you have to go find it out. When we did this example yesterday, we knew it's arithmetic. How do we know it's arithmetic? It's increasing by 5 every time, right? So therefore, you can use the same formula. And what did we know for this problem when we did it? Of the 3 things you need to know, what did we know? the first and the last, we didn't know how many there were. So we had to set up, use this formula to find the n on yesterday's problem. All right, then there's this one. Write this down. And this is what I was trying to say earlier, is that if I gave you this problem, you could use those formulas that are on the board, but you don't have to, because that's a linear rule, or in other words, it's a rule for an arithmetic sequence, which means you can use the rule we just used, the formula we just used. Now, you have to be careful with this stuff. I would highly recommend writing out the sequence first, or the series. If you plug in 10, what do you get? And then you plug in 11 next, which gives you 17. You plug in 12 next, which is 18. And then let me jump to the end. What's the last number? 38 is 32, plus 6 is 38. Okay? So here's the deal. Let me write down the formula, or some formula, that applies. This is an arithmetic sequence because it's going by ones. And so if you want to use this formula, there's kind of the disconnect here. What I'm saying is, write out what the summation problem represents, and then forget about the summation problem and just focus on the set. Okay? And it works just fine. And frankly, anyway, the catch is you need to figure out how many numbers are listed here. Okay? I mean, obviously the first number is 16, the last number is 38. But how many numbers is that? I heard a 22. Is that correct? The answer is no. You're on the right track. It's not 22. This is a little bit of math people always mess up. Okay? Let me give you an example of what's going on here. First of all, I don't know if this will help, but there's 3 people in this row. Yes? 3 people? First, second, third. If I do 3 minus 1, gives me 2. Not 3? And so that's what I'm saying, is when you subtract, look, the answer is that there are 23 numbers listed there. This is the 10th one. I mean, this is the 10th. N is 10 here. N is 32 here. Essentially, when you subtract, you're saying, okay, to get from 10 to 32, I have to add 22 onto it. Or in other words, there's like 22 gaps. But you're trying to count how many numbers there are. So you have to add 1, basically. You subtract and add 1, is what I'm saying. If you add, 100 fence posts, and you number them, 1, 2, 3, all the way up to 100. Well, if you take 100 minus 1, you get 99, which shows you how many gaps there were between them, really. Okay? Plus 1 tells you there's actually 100. One more example. You have your yard. You want to put a row of bushes on one side of your yard, okay? 30-foot side. And you want 3-foot spacing between the bushes. How many bushes do you have to go by? Forget about. I want 3-foot spacing between. Okay, and the answer is 11. Okay, you say, okay, I said 30 feet, 3 feet between. Divide, I get 10. But that's 10 gaps. 10 3-foot gaps does equal 30 feet. But how many bushes do you have to buy? 11. Like 1 and then 10 more. So that's a little bit of math that people don't realize. Frankly, I think lots of people, it comes up infrequently, and it's just a pain, and so sometimes they just avoid the problems that involve that. And so here, I'm saying, you're going to mess up the whole problem if you don't realize there are 23 and not 22. By the way, just to make it even more painfully obvious, what if I change this from a 32 to just a 12 here? Well, then that'd be 10, 11, 12. I would just have those 3 numbers here, wouldn't I? Well, once again, there are definitely 3 numbers in that sequence. If I do 12 minus 10, I get 2, plus 1 is 3. All right? All right. So after all that, let's finish this. These numbers add up to 54. I would take half of first. What's half of 54? 27. And I'll leave it to you to multiply out to 23 and to 27. So try to avoid multiplying that out. I mean, I'm doing too much calculations. Yeah. Frankly, usually it doesn't matter who it is, even if it's your parents. I'll make one exception. It's, what is this product? What? I don't think so. Yeah. Now listen, when I did this first period, frankly, we never threw a problem exactly like this in this unit, trying to use these formulas. And so I did it the safe way. And I went back and looked at it and said, okay, what I just showed you will work. And if I give you on the next unit that we start tomorrow on geometric sequences, you do the same approach where you use whatever summation they give you to write out sequence. And since it's geometric, you use the geometric formula. And all you have to do is figure out how many terms there are. It works, okay? What I showed you will work. But it's a shortcut, really. In other words, what I'm getting at is if I did this, I could take this approach. I could find the sum of the whole thing. In fact, here, if I wanted the sum of all 32 terms, then it'd be 32 terms. If I want to go from the first term to the 32nd term, what's the first term? If you plug in 1, what do you get? And if you plug in 32, you get 38 for the last term. And I can do that, which will give me the sum of all of the 32 terms, but I don't want that. I want the 10th through the 32nd. So which ones do I not want? The first through the... And so if I do the formula again, now I'm going from the first to the 9th. So the first was 7. What's the 9th? Huh? I can't hear you, I'm not. 15? I thought that's what you were saying, but my hearing's bad. So I could do that. And so this is the slower but more straightforward way. And so find the sum of all 32, find the sum of the 9 you don't want, subtract those two, and you'll have 621. So it's slower, but there's no pitfalls. Here, the shortcut I showed you, there's a good chance you're going to use 22 and get the wrong answer. You get the wrong answer faster, but you're wrong. So be careful, okay? So there's your two options in that problem. Yeah, remember that little, I don't want to call it trick, but that little bit of math that you're trying to go from, this term of the sequence to this term of the sequence, subtract and add 1. All right, read that. And just watch. I'm not going to have you write this one down. If anyone has a calculator, break it out, please. But when do we get it out of here? 10:30. So, okay. And we're going to do the quiz right after this. It'll be partner quiz, I decided. So be happy. All right. Look, I'm going to write down the money. So it's $10,000 first, and then $12,500 for the next $10,000, and then $15,000 for the next $10,000, and so forth. So that's our sequence. And so, like I said, this is how much they get for the first 10,000, second 10,000, third 10,000. If you want to find out how much money they made for the first 30,000, that'd be the sum of those three, wouldn't it? Okay. Now, so I'm saying this is for one 10,000, for the second 10,000, for the third 10,000. I want to go to n equals what? How many 10,000s is that? That's 10,000s? So I'm saying I just need to sum up the first 50 terms in that sequence. It's arithmetic because it's going by, well here, actually I need this. It starts with 10,000 and you're adding 2,500 every time, right? And to get to the 50, you add 2,500 49 times. I need someone to do that. Someone has a calculator, do the math. That's 10,000 plus 2,500 times 49, and tell us what the 50th term is. So no one has a calculator. Okay, thank you. Good, that's correct. And then we do a sum formula. We're trying to sum up those 50 terms. So it's 50 times the first term, which is what? 10,000. So do this for us, plus what you just said, divided by 2 equals a big number. What do you get? And there you go. So I'm just saying, if the situation turns out to be arithmetic in nature, then you can use that formula for that.